The next pricing strategy that can be used is second degree pricing. Now, second degree price discrimination is the practice of charging different prices per unit for different quantities of the same good or services. So it might be a simple example, but think about bulk purchases. Consider the price of 1 can of beer versus if you bought a tray of 24 beers. The price per unit is lower if you buy the tray because of buying in bulk or a larger quantity. So you get some quantity discount. I think about it when I purchase milk. Sometimes I'm in a hurry and I just run in and grab 1 carton of milk and it costs 16 Rand for one. However, if I bought a box of 6 milk, it may be between 70 to 80 Rand for the box of 6 milk. So there I gain a quantity discount. Another example of secondary price discrimination is block pricing. Now, block pricing is the practice of charging different prices for different quantities or blocks of a good. So, figure 11.4 is going to demonstrate this idea of block pricing. So, in this figure, you can see that your average cost curve and your marginal cost curves are declining. And that is demonstrating that there are economies of scale because the average and marginal cost curves are declining. Now, if there was a single price charged, then the price would be P0 and the output you can see would be Q0, right? However, there are 3 different prices for 3 different blocks. So here, different prices are charged for different quantities or blocks of the same good. So let's have a look at when price P1 is charged. It is charged for the first block up to quantity Q1. P1 is charged. Then the corresponding price for the second block here is P2. And then the third price being charged is that of P3 for the third block. So it's the practice of charging different prices, P1, P2, P3, for instance, for different quantities or blocks of a good. So with second degree price discrimination, consumers can be made better off because output is being expanded and there is a lowering of cost. So you can see at a single price, output would have been Q0, but as a result of applying secondary price discrimination, consumers are better off by expanding output. If you see the third block extends to Q3 and a lowering of cost. The final type of price discrimination is third degree price discrimination, and that is the practice of dividing consumers into 2 or more groups with separate demand curves and charging different prices to each group. So if you think about some consumers, if you were to divide them into different groups, perhaps their demand is more inelastic than another group, for instance. So again, there must be some knowledge of the consumer's willingness to pay and the elasticity of that particular, the demand elasticity of that particular group. Now, again, there's lots of examples that can be thought of. A common one is aeroplane or airfare prices. If you think about someone traveling, going on holiday, you tend to book your package and your aeroplane flights well in advance, and hence you get a lower price. However, with business travelers, because they may book on relative short notice, they tend to pay a higher price for business travel. Another example is thinking about students and pensioners that may end up paying a lower price. If you think about going up the cable car or to Kirstenbosch Gardens, you typically see that the prices for your pensioners and students is lower than the price charged to your normal visitors to those sites, for instance. So in order to practice third degree price discrimination, clear consumer groups must be created. Another example is thinking about your different consumer that would purchase a branded product versus a no-name product. I may purchase certain no-name Checkers products as opposed to a branded product, even though the product may be the same inside, but you may find that some consumers won't purchase the no-name branded product, even though the contents is similar. So, in terms of creating those consumer groups, how do they go about it? So, if third degree price discrimination is feasible, how is the firm going to decide what price to charge each group of consumers? Now, we know that however much is produced, the total output is going to have to be divided between the groups of customers, such that the marginal revenues for each group are equal. Also, we know that the total output must be such that the marginal revenue for each group of consumers is going to be equal to the marginal cost of production. The problem of how a firm must decide on what price to charge each group can be shown algebraically, and then we're also going to look at it graphically, right? So incremental profit of the last unit sold must be zero. So before we get to that point, let's look at what we have here. So we are going to let P1 be the price charged to the first group of consumers, and P2 is going to be the price charged to the second group of consumers. Then we also have total cost of producing the output. Total cost, capital C, is a function of Q or output. And since it's total cost, of course, we are looking at the total output. And total output, Q, with the subscript T, is given by the output or the quantity for the first group and the quantity for the second group. So adding the outputs or the quantities to each group will give you your total output. And then you have your total cost for producing this total output. Now we know that profit is the difference between your revenue minus cost. Here is your cost portion, but we also know that revenue is price times quantity. But remember, we've got two distinct groups here. We've got our first group and our second group. So saying price times quantity for the first group plus the price times quantity for the second group and summing that represents your total revenue, and revenue minus cost would give you profit. Now, incremental profit, hence we see the change here. Incremental is telling us that change or that additional profit from that extra unit that is sold, the revenue difference, the cost. So the incremental profit of the last unit sold, right, that's that incremental profit, must be equal to zero. So we're going to set the incremental profit of the sales for group 1 equal to 0. So therefore, incremental revenue, remember this represents profit, incremental revenue of the extra sale for group 1 is essentially the marginal revenue for group 1. And here we've got the incremental cost or the extra cost of producing one more unit, and this is your marginal cost, and it must be equal to 0. So therefore we can say marginal revenue, which is this portion, if we take that over, is equal to marginal cost. And this is the marginal revenue for group 1. So similarly, we can set the incremental profit of the last unit sold for group 2 also equal to 0, and what you'd get is the marginal revenue for group 2 is equal to the marginal cost. So hence, both of these are equal to marginal cost. So hence we can state that the marginal revenue for group 1 is equal to that of the marginal revenue for group 2, and it must equal the marginal cost. So we can put it all together. So the price and quantity must be such that this holds. This latter part about determining relative prices, it stems from the rule of thumb for pricing, which is not prescribed. Remember, the rule of thumb for pricing is dealt with in chapter 10.1. It is a small section and it's not prescribed for second year. So you may have a look at these formulas for knowledge enrichment purposes. This latter part over here, um, section 11.2, but it is not going to be tested. However, you should understand this portion. Now let's have a look at the next figure, figure 11.5, which shows third-degree price discrimination graphically. So we have two demand curves. One you can see is less elastic than the other, and which is that? So here you can see this demand curve is steeper or less elastic than this demand curve over here. So it represents the demand curve for two distinct consumer groups. So consumers are divided into two groups with separate demand curves. And we saw that here we had a steeper demand curve, and this is the corresponding marginal revenue curve for this demand curve. And then here we have a more elastic demand curve, and this marginal revenue curve corresponds to this demand curve. Now, the optimal prices and quantities are such that the marginal revenue for each group is the same and equal to marginal cost. Remember the algebraic derivations. So let's quickly have a look. Now, the sum of the marginal revenue for group 1 and the marginal revenue curve for group 2 gives us the marginal revenue, the total, which is this dashed line. And where the marginal revenue total intersects the marginal cost is at that point, and this gives us our total output QT, where MR and MC intersect. Now you know that the marginal cost must be equal to the marginal revenue for group 1 and marginal revenue for group 2. So if we draw a line, a horizontal line, across to our vertical axis, we are going to see where this amount or this value for marginal cost is going to cut our marginal revenue for our two curves. So for group 2, it cuts at this point over here, and that represents Q2, the output for group 2. And if we trace this further back in a horizontal line to marginal revenue for group 1, is going to represent the output for group 1. So hence we get Q1 and Q2 because at that point marginal cost is equal to the marginal revenue for group 2 and for group 1. And now we can see what the prices would be. So for this output Q1, we can see that the group 1 with the demand curve D1 is going to be charged the price of P1. And then group 2 would get this output Q2, and with its demand curve D2 is charged a price P2 on this more elastic demand curve. So you can see on the more elastic demand curve D2, it is charged a lower price P2. So marginal cost depends on the total quantity that is being produced. And note that Q1 plus Q2 is chosen such that MR1 is equal to MR2 is equal to marginal cost. The final figure, figure 11.6, shows that when the demand is small for one group of consumers, then it's not worthwhile to sell to this group. So if we have a look, even if third-degree price discrimination is feasible, it may not pay to sell to both groups of consumers because marginal cost is rising. You're the first group of consumers with demand curve D1. They're not willing to pay much for the product. So it is unprofitable to sell to them because the price would have to be too low to compensate for the resulting increase in marginal cost. So the firm is better off selling just at P star for an output of Q star to this particular group of consumers. So no sales to smaller markets in this case would make sense, even if third-degree price discrimination was feasible. Now, the final example is just for knowledge enrichment purposes.